From shifting depictions of diversity to the rise of socially conscious storytelling, this project explores how social trends shape and are shaped by the movie industry. The movie industry reflects societal, cultural, and technological changes. This project explores how audience ratings and genre trends have evolved since the 1950s, revealing how these shifts align with broader transformations. To address these issues, two IMDb datasets were merged, one detailing movie genres and production years, the other providing audience ratings. A pre-processing phase normalized genres to the primary category and removed incomplete records. Data analysis focused on trends in ratings, vote counts, and production volume across decades. The analysis faced challenges with IMDb data in terms of missing metadata. Additionally, the diversity of movie genres complicated categorization and interpretation. The findings highlight significant patterns. First of all, Westerns declined sharply after the 1960s as societal values shifted, though the ratings remained stable. Drama maintained consistent ratings across decades, with a production and engagement peak in the 2000s. Finally, sci-fi and action genres surged in popularity and ratings starting in the 1980s, driven by advancements in visual effects. Future research could address IMDb's limitations by integrating additional datasets such as social media sentiment, box office performance, and regional film databases. Exploring genre crossovers and audience reception of hybrid genres could provide further insights into modern trends. Thank you for your attention.
Are you a researcher? And are you tired of assessing privacy-restricted datasets? Then this is the project you have been waiting for. Finally, you will have a way to automatically generate the metadata. Now begs the question, how do for guys who didn't even know how to use the print function in Python 2 months ago manage to do this? Fortunately for us, we had the greatest supervisor of all time on our side that helped us set up a step-by-step guide on how to take on the project.
Write that down! Write that down!
We divided the project into 2 parts, with the metadata creation as the first part, and the metadata enrichment as the second part. With the first part, the aim was to automatically extract the basics of the metadata using Python and its pandas library. The output was a CSV file looking like this, including the column names, column count, row count, value type, centrality measures, and the missing values count. Everything had gone smoothly up until this point. However, we sensed strong tide changes on the horizon. You see, not all the data could be automatically extracted from the encrypted file. Some required embedding. When we reached the embedding stage, a crisis unfolded as we encountered our first challenge with the code.
What the hell is going on, bro? Bro, what the hell is going on, bro?
Luckily, we figured it out together with our supervisor. We use embeddings to compare the dataset column headers with a controlled vocabulary, identifying the closest matches. We use LLMs after the users input the URL and topic, which Grok API uses to generate a relevant title and description. I know this sounds quite abstract, but I won't tell you more. So make sure you visit us during our poster presentation where we will explain everything in detail, because you don't want to miss this.
Welcome to our project, Understanding and Updating Provenance of Artworks from the Colonial Past. In this research, we explored motifs and symbolism in Chinese art spanning the 17th to 20th centuries. Our approach combined machine visual analysis and human analysis with traditional literature research to contextualize the artworks historically. To obtain our dataset, we used data from the National Museum of World Culture. Using a Sparkle query, we filtered Chinese artworks by specifying the 17th to 20th centuries. We limited the output to 10 paintings per query to avoid duplication, ensuring we captured 5 unique works per century. As you can see here, the line of code that specifies a century is circled for clarity, and it can be easily adjusted if you want to explore other centuries. So after retrieving the selected paintings, we proceed with machine analysis using CLIP. This is the code we're working with, and the output showed variations across paintings from different centuries. Take this 20th century painting as an example. It features flora and botanical motifs that carry symbolic meanings tied to the species depicted. Additionally, the calligraphy expresses wishes, blessings, or poetic sentiments, an integral aspect of Chinese art. The results, as you can see in the bar charts, show that while the software successfully identified broad themes, it struggled with finer details. This highlights the importance of combining machine learning with human interpretation. Our analysis revealed 4 recurring motifs: botanical elements, avian subjects, maritime vessels, and architectural landscapes. Clips showed promise in identifying shared motifs across large datasets. In conclusion, pattern recognition tools like CLIP have potential in humanities research. While they cannot replace full human analysis, they serve as valuable aids in identifying commonalities within extensive collections. This marks the end of our video. Thanks for watching.
Large language models are revolutionizing research in the social sciences and humanities, offering tools to streamline data queries and analysis. This study evaluates Muse-IT AI, an LLM-based platform designed to simplify dataset metadata queries using natural language. The tool is built on the DANS SSH dataverse, encompassing nearly 8,000 datasets and over 400,000 files. Muse-IT leverages knowledge graphs to transform user queries into Sparkle and retrieve metadata. Our paper focused on 3 key criteria for evaluating the tool: accuracy, relevance, and usability. While Muse-IT demonstrated its potential, our findings revealed significant limitations. In some cases, the tool provided accurate, nuanced responses, effectively synthesizing metadata. However, it frequently retrieved information from the wrong dataset, leading to hallucinations and inconsistent performance. When functioning correctly, responses achieved a mean accuracy of 80% and a relevance score of 3.8 out of 5. However, overall scores were much lower, 33% for accuracy and 2 out of 5 for relevance, highlighting fundamental challenges in dataset alignment and metadata understanding. Usability also emerged as a critical issue. While the interface is simple, it lacks guidance for first-time users. Features like help functions, clear explanation of the tool's scope, and metadata-specific query tips could significantly improve accessibility and effectiveness. Some of the recommendations we devised include refining the algorithms and server resource levels to reduce hallucinations, expanding training datasets, and enhancing the user interface. Overall, we believe that our findings suggest researchers should use Muse-IT as a supplementary tool for specific metadata tasks rather than a standalone solution. While Muse-IT exemplifies AI's growing role in SSH research, offering a glimpse into a future of seamless academic workflows, unfortunately, our testing found significant improvements were required to make it a scalable, reliable tool.
In today's media landscape, the way tragedies are reported can shape public perception just as much as the events themselves. When a conflict erupts, headlines flood our screens, framing the narrative before we've had a chance to process what's happening. In our project, we examined how 3 major UK outlets, BBC, The Guardian, and The Telegraph, covered the Israel-Palestinian conflict in November 2023, following the October 7th attack. We used topic modeling, sentiment analysis, and a terminology glossary to see how language might influence our understanding of the conflict. Our findings of the topics chosen by the machine learning algorithm suggest differences in each outlet's focus. The BBC tended to cover live updates and humanitarian issues using words like released and taken. The Guardian offered more historical context and cultural angles with words like school and Hezbollah. The Telegraph often highlighted criticism as seen by their repeated claims about other media outlets and issues related to anti-Semitism. Sentiment analysis showed mostly negative tones throughout, which is common in war coverage, but we did see some moments of hope in stories about hostage releases, for example. Meanwhile, examining key harmful terms like hostages killed and terrorists revealed how they can carry bias or shape perceptions of the conflict. Given all 3 media outlets use language that could shape perception in different ways, the Telegraph appeared more likely to employ terms that might subtly influence readers' views of the conflict. However, many terms such as ceasefire carry a different connotation based on the context given. Overall, our study underscores how words can frame public understanding of global events. By combining computational tools with human insight, we aim to encourage critical engagement with the media we consume.
This is the Netherlands Institute for Sound and Vision. It is dedicated to media culture and serves as a large archive for all kinds of media. Together with Mobile Collectie Netherlands, they are working to make mobile heritage accessible to a wider audience. Mobile heritage includes vehicles like cars, planes, or bicycles, which will be presented digitally on the website of MCN. To add videos like this to a new digital platform, labeling is needed. Visitors want to know when a specific car, plane, or motorcycle appears in a video. To help Sound and Vision explore their options, we look into how useful AI image recognition is when identifying and labeling mobile heritage videos. First, we looked at how the vehicle types are defined. We took labels from the GTAA and Fisarius already in use by Sound and Vision and gave them more specific definition. In order to test how well the model would perform, we looked at the selection of the films ourselves and created a gold standard, a perfect result. If the model performed well, it would produce similar result to our gold standard. For the model we choose YOLO, or You Only Look Once, as image recognition model. Even though most of us can easily recognize that this is a car and this is a boat, it turns out that for AI this is significantly more difficult. Here the vehicle type was correctly recognized, but here it clearly makes mistakes. We tried to train the model with our own data to enhance the accuracy, but because we had too few examples, it performed better when we didn't train the model. In the end, we gave Sound and Vision our list of definitions, both in Dutch and English, to improve accessibility of the terms in use. Our gold standard that can help with future model performance testing, and our paper that gives our findings on the opportunities and limitation of using AI image recognition to recognize mobile heritage.
During the German occupation of the Netherlands in World War II, the Nazis orchestrated a systemic program to strip over 135,000 Dutch Jews of their belongings, seizing assets worth over $6 billion today. The looting of Jewish homes represents a profound injustice, rounding off the systematic persecution and discrimination endured under Nazi rule. However, questions remain about which locations and social classes were most affected. To address this, we analyzed the Rosenberg archives, which document the activities of the Einsatzstab Reichsleiter Rosenberg, a Nazi organization tasked with plundering cultural, religious, and private possessions across occupied Europe, including the Netherlands. We cleaned the data sets, retaining only the item ID, worth, address, and social class. Since the original data listed property values room by room, we aggregated the worth for each building. We also combined street names and cities into one cell, normalized some addresses for consistency, and created a social class variable. Households owning less than 200 guilders were classified as low class, those under 1,000 guilders as middle class, and those above 1,000 guilders as upper class. Lastly, we visualized the data in Google My Maps. A chi-square test revealed significant discrepancies between the observed and expected frequencies of property confiscations. Lower-class households were disproportionately affected, while middle-class households were less likely to be targeted. Geographical analysis of Amsterdam revealed that the lootings primarily occurred in the east of the city, including Amsterdam Ost and the former Jewish district.
Hello everyone. Our project explores engagement with HPV vaccine discourse on X across languages. HPV is a common STI linked to cancer, and vaccines like Gardasil are crucial for prevention. However, online disinformation fuels vaccine hesitancy and resistance. Studies show false information spreads widely, and anti-vaccine tweets get more engagement, often citing ineffectiveness, health risks, and distrust of pharma. We analyzed 5,183 tweets in 30 languages, filtering 636 HPV-related tweets, from which 238 in English and 398 in French. A key challenge is informal language and slang, making NLP processing harder. Our research asks, what are the primary topics in HPV vaccine discourse? Do they vary across languages? And how do users engage with this discourse? Does engagement differ across languages?
Like any other digital humanities project, our procedure is not at all linear. At the end, we decided to remove sentiment analysis as a part of our results and only keep regression analysis and topic modeling. To answer research question 1, topics in English and French primarily focus on alleged harm and distrust in institutions. The French dataset exhibits greater thematic similarity and internal overlap. Additionally, it presents more specific concerns about vaccination use in children and teenagers.
For our second research question, we found that tweets in French drive higher engagement and show greater variation. Engagement patterns differ by language. Tweets in French outperform English in all engagement components, while likes and retweets strongly correlate with overall engagement for both. Our findings reveal similar topics for both languages, but cultural differences affect word resonance engagement. Limitations include a smaller dataset, language imbalances, and limited analysis time. Future research could explore this information and sentiment in multilingual contexts. Current NLP tools still face challenges like language misclassification, low sentiment accuracy, and insufficient granularity in topic modeling.